All right, guys, this is number 22 on page 307 in your calculus workbook. This is one of those questions where you have to apply one of your limit identities. So if I actually summarize what those limits are, we have limit as x approaches 0 of sine x over x gives you 1, and the limit as x approaches 0 of cos x minus 1 over x is equal to 0. All right, so what we want to do is we want to manipulate this limit so that we get one of these two limits here. So here's an example where you have a tan x involved here. What you always want to try to do is, since we don't have any limits involving tan and only sine x and cos x, you want to apply one of your identities here. And that identity is going to get rid of this tan x and rewrite it as a sine over cosine. So tan x is the same thing as sine x over cos x. But this is still divided by 4x here. So we actually have a complex fraction here, a fraction within another fraction. So what we want to do is create, once again, one of these limits here. So which limit do you think we could create here? Number 1. So let's work with number 1 here. And so we're looking at the sine x here. Now, one thing to always remember that the argument should always match what's on the bottom here. And as you can see here, we don't have that situation here. So we have to create that. What could we do to create that situation here? What can we do to the top and the bottom here? We could multiply it. Remember, we want an x on the bottom there. So you're going to multiply the top and the bottom by 1 over x. Okay? Same thing on the bottom here. We're going to multiply that by 1 over x. So whatever you do at the top, you must do it on the bottom to preserve equality here. Okay? So what we're going to do here is we're just going to combine these two. So we're going to have sine x over x. But we still have that cos x on the bottom. That's not going anywhere. And on the bottom, we have 4x times 1 over x. And if I simplify that, we're going to simplify to what value here? 4x over 1 times 1 over x. These actually cancel out. So I'm going to have a 4 on the bottom. Okay, so let's keep going here. Remember, we wanted to achieve one of these two limit identities. And I can actually see that. Can you guys see that? Yeah. So right there, what is that value actually equal to? It's equal to 1. So we have limit as x approaches 0 is equal to 1 over cos x. Okay, are we all in agreement here? So 1 over cos x, all divided by what value? 4. Good. Okay, so you check at this point. Since we're evaluating when x approaches 0, can I simply put x is equal to 0 into this function now? Will I actually get a value? Well, let's check. We'll see. 1 over cos of 0 divided by 4. Okay, what's cos of 0 radians actually equal to? This is 1 over 1. Okay, over 4. So simplify. 1 divided by 1 is just going to simply give you 1. What's on the bottom here? 4. So what's the answer here? The limit as x approaches 0 is going to be equal to 1 over 4. And that's how you do that question.